the power of Transform CSS is the focus of today's session, alongside Transform Origin and the Perspective property. Let's start with some theory first. So the CSS Transform property, just like setting a relative position on an element, gives us the power to manipulate without interrupting the default document flow. Basically what it does, it only affects the element without pushing other elements around and messing with our layout. The transform methods that we can use are scale, rotate, translate and skew, and we'll cover these in a moment. One thing to remember, very important, is that we always need to write the transform property followed by colon to access the methods within it. So what we can see on the screen, I hope you all can see the screen, is simply an app.js file and an app.css file. And I have my browser Google Chrome open with an image that is called image1. And what I've tried to do here is try to have an image, just a black box with the horizontal and the vertical axis. And you'll see why this will be very useful in a moment. So what I've started with, I basically just set up image1 to have a height of 200 pixels and a width of 200 pixels, so effectively a square. So if we start with translate, so translate X and translate Y, move the element along the horizontal and the vertical axis. And of course it can take either positive to move it on the positive axes or negative values to move it on the negative axis. The shorthand for translate is translate parentheses X comma Y, and we'll see that in a second. So the way we tap into the method within transform, as you can see, you do transform colon and then you do translate. We're going to have a look at translate X first, and we're going to start with a length of, for example, 100 pixels. So I'm going to save that, and what it will do, it will basically move our element 100 pixels to the right. And I say to the right mainly because we have a positive number. If we were to say minus 100, it will move it to the left, and so on. In the same way as we use pixels, we can use percentages, for example. So we can do, I don't know, 40%, and that will effectively move the element 40% of its width to the right. If we do, say, 100%, it will move the element 100% of its width to the right. Moving on, we use, say, translate Y. This will, as I said before, move the element in the vertical axis, depicted by this red line here. So we say 100 pixels on the vertical axis, it moves it down 100 pixels from its original position. And in the same way, we can do 100%, and it moves it 100% of its width on the vertical axis. Again, for example, if we wanted the item to disappear from the page for whatever reason, we can have a transition after that or something. We can do minus 100% and we'll effectively position the element outside of the browser window 100% on the vertical axis. As I said, the shorthand for translate is effectively X comma Y, and how we use that is say for example we do 200 pixels on the horizontal and then I don't know 50 pixels on the vertical, and that's the result that we get. So 200 on the horizontal, 50 on the vertical. Any questions so far?
No, mate, all good.
Nice.
No.
Brilliant. Okay, so I'll move on and let's discuss rotate. So rotate X and rotate Y. Rotate the element on its horizontal and vertical axis, and this is where things get a little bit tricky because it's a little bit hard to grasp at the beginning, and you see the image will be very useful when trying to visualize what rotate does. So the main purpose of that image is so we can see how the element begins to disappear as we get closer to say 90 degrees and 270 degrees as the image rotates. We also have rotate Z, which effectively rotates the element on its Z-axis, and the Z-axis is the one that goes in and out of our window. So let's look at the, say, rotate X, and rotate always takes degrees, so it doesn't take percentages and it doesn't take REMs or anything like that. It needs degrees to work. So say, I don't know, let's say 20 degrees, and we save. We start to see that image shrunk a little bit, but it's not really shrinking. What it's doing is rotating on these horizontal axis, but to our eyes it looks like it's shrinking. So we do say 40, it will continue to rotate. If we do say 60, continue to rotate, and if we do 90, what do you guys will happen? What do you think will happen, guys?
It'll disappear.
Nice one, nice. Yes, Adam, it will disappear because, as I said, it rotates 90 degrees on its horizontal, and basically it's just showing us the one of the edges that is not visible to us because it doesn't have any girth. So we do 110. Oh, sorry, 110. It will start to appear again, but it's completely flipped upside down. So we do say 160. You'll see that the Y letter depicting the vertical axis is completely upside down, and so is the X. So this is pretty much what rotate X does. It rotates the element on its horizontal, and rotate Y is effectively the same, but it does rotate the image on its vertical axis. So let's do 60. You see it starts to disappear. 90 disappears completely, and then you do 180, for example. You see that image is completely turned around on its vertical. I guess this is useful when you have an image and you want to rotate it quickly without actually changing the JPEG or the PNG file. You want a mirror of the image really quickly without actually transforming the image itself or doing anything else. This is something that is really useful. I guess the next method within the rotate property is rotate Z, and as I said, rotate Z is pretty much a clockwise or anti-clockwise rotation. So it uses the pivot point that we have, that imaginary pivot point that we have here, and it rotates the image, say 20 degrees. So it starts to rotate. Positive values rotates the image clockwise. Negative values will of course rotate the image anti-clockwise. So we'll do 60 degrees. You'll see that the vertical Y axis is rotated minus 60 degrees. Any questions? No? Okay.
That looks good.
Brilliant. Let's just move on I don't want to spend too much time on the basics. Move on to the scale method. And a scale, as the name suggests, stretches or shrinks an element. And you'll see what that means in a sec. A scale x and a scale y with values greater than 1 stretch the element, with 1 being a 1-to-1 scale, 2 being a 2-to-1 scale, or basically double the size of the element, and less than 0 values shrink the element. For example, 0.5 would be 0.5 to 1, or effectively 50% of its original size. I guess let's look at examples here really quickly. So we do a scale x, and then we do, say, for example, 1, and then you see that nothing changes. Scale 1, as I said, is scale 1-to-1, so nothing changes, still a perfect square 200 pixels by 200 pixels. But if we do, say, 2, scale of 2, so it's 2-to-1, so basically what it does, it stretches the element from that original size of 2x2 to 4x4. You'll see that what's happening right now is that some of our stretched element is going beyond our left boundary of our window. But we'll see how to fix that in a couple of minutes when we look at transform origin. But what we have to remember here is that the transform properties always look at our, as I said, our imaginary pivot point that we have here in our element. And it's not just on this image, it's on every single HTML element that we create in our web applications. So let's do, for example, as I said, 0.5. So 0.5 will effectively shrink the element by 50%. And again, we can do the same with scale y, and then scale 5 times, so 5-to-1, and so on. The shorthand, as for translate for translate is x comma y, so it's something like that. Oh goodness, x comma y, and what we do here is simply say, I don't know, 1.5 scale on the x axis, and then say 2 on the vertical axis. So you'll see that is stretched on both. If the second parameter is not specified, it takes the value specified already and it stretches the element on both the axes. So let's look at that, for example. So you see that the element is stretched on both the horizontal and the vertical axis. Any questions?
Oh, good.
Oh,
No, good, thank you.
awesome. Okay, let's continue with. I mean, to be honest, the last one that we're going to see, the last method that we're going to see within the transform properties is Q. And to be honest, I haven't had the pleasure, if I may say so, of using this method yet. And I'm not sure whether I'll ever use it. Ricardo may tell us otherwise later, but I don't know if you guys will find this method useful. But I thought it would be also relevant to cover it anyway. So let's look at how SQ works. So SQ basically skews an element along the X and the Y axis by a given angle. The shorthand again is X comma Y. And let's have a look at at an example. So let's do skew X, and let's say I'm going to do 20 degrees, and bear in mind that it takes degrees only. So if we do save, you'll see that the image is now skewed 20 degrees. There's an angle of 20 degrees on the horizontal axis, skewing our image. And if we do, say, for example, 60, again, there's an angle of 60 degrees there, skewing our image. And if we do 90, the image disappears completely. In the same way, we can do skew Y, and you'll see that there is that 20 degree angle on the vertical axis now, and again the same happens when you increase the degree, starts to skew the image even more, and if you do 90, it disappears completely. As I said, I've never used this before, and I'm not sure whether I'll ever use it. As you can see, this is just a normal PNG image, and the image gets really pixelated. It might be different with SVG files or whatnot, but something to bear in mind as well when using the skew method. Any questions? Have you guys ever used the skew at all, or Panos, have you used this much?
I haven't. I've used rotate a lot, but not skew.
Okay. Yeah, as I said, I don't really know what I would ever use this for, but I thought it would be, of course, relevant to cover it.
So from my side, I got some notes. I mean, I never use a skew neither. I'm probably just talking. I'm not talking anything relevant now, but
I definitely saw it before, but I don't remember where. I definitely reminds me of something.
So I think skew is one of the things that probably you don't know. You probably don't know it even exists. But it's interesting because historically speaking, on CSS, we've been always working with the feeling that many features are missing, and now a skew is a good example of how things are changing in the CSS side. Now CSS is giving you more options than you need in many use cases scenarios. Personally, I would use skews if I had to build some sort of 2D isometric game, because I think that plays really well with the idea of building 2D shapes using a specific perspective. But this is something that I just made up based on what you presented then. So yeah, if anyone has a good example of how to use a skew, I will be more than interested on listening to it.
Nice one. Thank you, Ricardo. So now that we covered the skew, that pretty much covers all the methods within the transform property. Just a quick reminder, and I guess we have to say, we have to remember that we are in CSS, and of course, if we have to transform properties, one followed by the other, or in different in different objects. Sorry, same object but different different place or different file. It will continue to apply the last one. So it goes from top to bottom, and it will apply the last one. So for example, we do 100 pixels here. At the moment we have skew X 20 degrees, but now that I've included this translate Y, you'll see what happens. So this gets done first, but then when it sees the translate Y 100 pixels, it completely ignores the skew X. So it's something to bear in mind there when using transform. And I guess that leads us nicely into what I want to cover next. So you might be asking, okay, so how can we use multiple transform methods without having this issue here? So I guess what we can do is we can use them in tandem. We can use them by simply separating them with spaces on the same line. But what we have to remember, guys, is that the order is incredibly important. So let's look at these examples. So we have skew X 20 degrees, and then translate y 100 pixels. If I save that, you'll see that effectively what has happened is I am seeing the 20 degrees skew on the x-axis, and I'm also seeing that the image has been translated 100 pixels, contrary to what happened before. So this is the way we can have multiple methods in a single line. But what happens, for example, if we have, say, something like this? And this is where I want your full attention, if I may. So we got, say, rotate Z 45 degrees. We do, say, for example, a scale, I don't know, 1.5, and then we do translate X, say 200 pixels. Let me just stretch the window so you can see all the code. What do you think is going to happen here, guys? Anyone has an idea?
I don't. It would be interesting to see what happens.
Okay, brilliant. Thank you, Panos. So this is, as I said, this is where I want your full attention. So what's going to happen here is I'm going to press save, and you'll see that that's not maybe what some of you expected. So what's happening here is, first of all, is rotating the element on the z-axis 45 degrees. So you see there is a 45 degree rotation on the z-axis. Yeah. We are scaling to 1.5, so it's growing by 1.5 times, and we are translating on the x-axis 200 pixels. But wait a minute, the x-axis surely is the horizontal axis. Why hasn't it moved just here? Oh, because we changed that axis. So the new horizontal axis is not the flat axis, it's this new horizontal white line that we see. So what happens if we want to rotate it, but we want it here? So, and this is where the order becomes really important. So I'm going to simply cut and paste the translate. And what's going to happen here is it will effectively do translate first. So it will move the item, the element to the right 200 pixels. It will rotate it and it will scale it. So let's see how that looks. So that's really important, and that is one of the things to remember when playing with a transform property. If you're not seeing what you wanted to see, or the outcome isn't what you expected, just make sure that they are in the correct order.
Do you mind refreshing the page again, Dan?
Oh, that's it.
Because on your first example, you kind of like, you could see a bit the rotation, whereas now it's kind of like, at least for me, it's a bit jumping. But it's interesting to see how moving things around like has a different effect.
Yeah. So yeah, it's just I guess it's applying the methods from left to right, and if we have the rotate on the left, it will rotate it first, and if we translate it on the horizontal or the vertical axis, it will rotate it. Sorry, it will move it on its new vertical or horizontal axis. I hope that makes sense.
Now, I'm not sure if you've done that. Like, how about if you have multiple classes on an element and apply those transform, like translate X, rotate, and scale in different 3 classes? Does that make sense?
I guess it does make sense. I haven't played with the classes, but it'll be interesting to see what the outcome of that would be, whether it actually takes it or if I don't know, maybe it overrides the previous depending on the order they are laid out on the CSS file. I don't have an answer to that, Panos, unfortunately, but it will be interesting to see.
It's just interesting to see.
Yeah. Okay. So any other questions on this?
No, from my side, that sounds very interesting.
Okay, brilliant.
All good.
I'm just going to move really quickly. So one thing to note is something that is beyond the scope, but is the transform matrix. And this is, I don't know, is I guess seconding what Ricardo says often is highly controversial in my opinion. So transform matrix takes, what it does, it basically combines all the 2D transform methods into one, and it takes 6 parameters which allow you to rotate, scale, translate, and skew your element. The parameters are as follows, and this is where it gets a bit dodgy, if I may say that. So scale x, comma, followed by skew y, comma, followed by scale y, comma, translate, translate x, and the last one is translate y. And then bear in mind that we have to, let me just stretch this a bit. So bear in mind that we have the matrix, and then we have the parentheses, and then we have the individual methods within that original parentheses. As I said, this is beyond the scope, but I would welcome your thoughts, and I don't know if you guys have used this before, but to be honest, I find using the multiple methods in a single line, as we saw in the previous example, better and easier to manipulate than using the matrix. Sometimes the outcome of playing with these, so inputting the different values, is not as desired, because the order of the methods cannot be changed. So you may have, I don't know, you may have something that I don't know, you may be picturing something in your head, and when you do this, it doesn't actually work as expected. But it's definitely something that you guys should look at, and maybe play with it on your own time, if that's okay. Okay, what I'm going to be talking about now is the transform origin, and this is something that is relatively new in CSS. Again, I'm not sure if you guys have ever used it, but it's one of those things that I find incredibly important to understand in order to fully appreciate the power of transform, and understand how the elements are being impacted by what we are writing on our CSS. And I've prepared a very, I'd like to say, simple slide to try and explain what CSS and HTML, how they see our elements and how the transform origin work. So if we look at the gray box, let's say this is our element, and the pivot point that I was talking about earlier is right in the middle, so where the vertical and the horizontal axis meet. And these, under the transform origin property, have default values of 50%, 50%, and 0 pixels. So it's X, Y, and Z. And also they take default values of center, center, center. What happens? So if we have say for example, a rotate Z, you'll see that when we flip, when we rotate the image, say 45 degrees, it rotates the image using this pivot point. So effectively rotates the image on this pivot. But if we move it, say to 0, 100, 0, or left bottom 0, it will rotate the image using this new pivot point. Does that make sense?
Yep.
Okay. Thank you. So the syntax, as I said, is X, Y, and Z. X take either left, as in here, it takes center, or it takes right. So left, center, and right. And Y, it takes top, it takes center, and it takes bottom. And of course, the Z axis takes a distance on the Z axis. So let's have a look at how that works with an example. So let's look at this. So transform, and then let's do rotate Z, for example, 30 degrees. And then what we're going to do is use the transform origin property, and we're going to say, let me just get rid of that for a second. So we're going to save that, and you'll see that is rotating on this axis, on this pivot point. We do transform origin, say left top 0. You see that the origin, as per the PowerPoint slide, is moved to the left top pivot. So it's no longer rotating on its original pivot in the center, 0, 0, 0, or center, 0, is now rotating on left top 0. So it's rotating on this new pivot point. Does that make sense? Okay, cool. Thank you, Panos. So let's look at another example. So I'm going to do, say, scale. And we saw when we looked at a scale, we do, say, I'm going to get rid of that really quickly. So do a scale, and you see that it's stretching the element, and some of the element is not visible anymore, and that's because basically it's using the pivot, and it's stretching it on the positive axis, and then one to the negative axis, and some of our element is not visible. So what happens if we were to use, say, transform origin, say, I don't know, let's do left top 0. What do you think is going to happen, guys?
I'm going to move the element a bit on the top and a bit left dimension.
Okay, thank you, Panos. Let's look at what happens. So I've set transform origin left top. So I have effectively, I'm going back to the PowerPoint. So originally it's here, and I moved it to left top. So I've moved it here, and I'm asking CSS to stretch our element twice. So what's going to happen effectively is this. He's going to stretch our element from this point here. So he's no longer going to...
All right.
Go on.
So it doesn't move the pivot there. I'm going to be confused. I thought it does. So transform origin becomes the pivot point.
That's it. That's the pivot point, yeah.
Yes, but if you go back to your diagrams,
One sec.
Because I think I misunderstood. I thought where the x and y intersect, so that's the origin basically.
Hmm.
I got it like it doesn't. If you think the origin as a top left, wouldn't that and essentially scale be on the left and be on the right from the origin? I'm not sure how to explain this, or I'm not even sure if that makes sense what I'm saying. So we saying transform origin left top 0, and then that's basically it. And when you go on your browser, that does basically scale only towards the right side.
Correct. So it's scaling it from this point, and
so it doesn't essentially become the pivot. The origin.
I guess that's what the theory say. I guess what you're saying that it should potentially stretch on the top as well as it did originally, right? Yeah, I think what it does is also not just moving the pivot, but also the boundaries of the element. So
I think it'd be good to kind of give that a go.
Yeah. So let's say, we can do that. Let's say with y as well. Say, so again, it's using the new pivot and it's stretching it on its vertical axis twice. And when it gets, I guess when it becomes, I guess useful, is when you have to, I guess, get rid of the image to transition it into I don't know, to do a transition, and then when you hover over it, it will become visible, I guess. That's something that we can do as well with transform origin.
Or maybe like animating some icons or something.
Yeah, exactly. Okay, Ricardo, are we okay with time, or?
I think we should consider wrapping it up at some point then.
Okay, that's fine. So what I wanted to touch on really quickly is the perspective. Perspective allows us to add a three-dimensional field to an element, and the value given to the property defines how far the object is away from the user. So basically, a lower value will result in a more intensive 3D effect than a higher value. And perspective basically is used on the parent element, but the parent element doesn't actually get affected, only the children. And we also need the transform method to be able to see the effect perspective has on its children. For example, we can have a rotate x to see the perspective property being applied on an element on the children. Conscious that we're running out of time, but I would invite you guys to have a look at your own time. If you have any questions, do let me know.
Dan, not sure if we've lost you, or maybe that's my fault. Can you hear that now, guys?
Yeah, I could hear him just now. Yes, about if we have any questions.
Are you still? Can you hear me?
Yeah, now we're nice.
Okay. Okay, guys, if you have any questions about perspective, I had prepared an example. I can share that with you on Slack if you want to play with it and see how that works.
Great. Thank you very much, Dan. I think that was very interesting. I particularly like when you talk about the multiple chaining of multiple transform properties. Something I never experienced personally. So it's great to see how altering the sequence may have some side effects on the eventual outcome. Yes, a couple of notes from my side. So obviously in CSS there are multiple ways of dealing with different type of animations or different type of visual representation of your component, right? Something we should consider at some point is performance. Not all the CSS rules have the same performance because of reasons that go beyond the scope of this session, right? That is something that we should definitely consider. So obviously, transform can be animated, and I mean, if you're curious about it, you can Google a bit. But it's interesting to see that transform has proved to be across all the main browsers way more performant than other equivalent alternatives. So for instance, if you want to move a box from left to right, you can either animate the left property or the right property or whatever, or of course you can use transform with translate. Yeah? So there are ways to move boxes using transform, of course. Yeah? So the latter using transform has proved to be way more performant. So that's something to consider, especially when talking about mobile devices. At Codery, we migrated many animations, especially the ones, you know, on the menu, when you expand the menu, you got a panel coming from the left. When you open the notifications panel, you get a new box, a rectangle popping in from the right. So all these sort of things are implemented based on transform, because it has proved to work much better. And a final thought from my side, yeah, that's fantastic. We can build so many cool things with transform. Yes, guys, be careful with your browser stack compatibility. Yeah? Not all the browsers, unfortunately today, support all the sexy features offered by transform. I'm gonna send you a link on Slack where you'll find out which properties of CSS free transform are supported and which properties are not. It is true that these days the majority of the browsers, they made a big effort. They made a big effort on supporting everything. About 2D transform, I believe every browser supports everything these days. About 3D transform, yeah, I think this is pretty much really well supported. Obviously, ignoring things like Internet Explorer and things like that. But it's something that you should definitely be aware of. That not every browser may support all the nice transform properties that Dan has presented today. Yeah, apart from that, from my side, that was it. Thank you very much, Dan, for the presentation.
Brilliant. Thank you guys for listening.
Thanks, mate.
Right.
Thank you.
Thank you.